Right, this 8-6 in advanced geometry. Today, talking about the law of sines and the law of cosines. How do you know when you need to use either law? Well, first of all, they'll give you some triangles, and the thing is why the old school trigonometry of SOHCAHTOA, which is called right triangle trigonometry, doesn't really apply for us, is because we don't have a right triangle. This is 80 degrees, this is 40 degrees, and this right here would be 60 degrees because all three angles have to add up to be 180. So we don't have a right triangle to get going on. Now there's two laws. There's a law of sines and there's a law of cosines. This whole front side of this practice sheet will be about the law of sines, and I just kind of do it like this. Sines and cosines. Sines kind of sounds like the word side to me, right? And you know you want to use the law of sines when they only give you one side length. As you can look in this problem, we only know one side length. It is 12. Cosines means more than one. Co means more than one. So that means they give you more than one side length. So all of these problems on the front page are the law of sines because they only give us one side length. So here's how it works. It says that the law of sines is this proportion, the sine of big A over little a. Well, remember, little a is a side length, and capital letters are the angle that they're talking about here. So the sine of big A over little a is the same as sine of B over little b, and the sine of C over little c. Here's how it boils down. You don't need all three things at one time. You only need two. You need a side length and an angle measure that are across from each other, right? This would be an angle measure of 40 degrees and a 12 that's across from it. So we can start with the sine of that angle over that side will be proportional to, I need if they're asking me to find x right here, I need to know the angle across from x also, which I do, so it's the sine of 80 over x. It's always the sine function because it's the law of sines, and the angle measure always goes next to the trig function right there. So the way we solve this is by cross multiplying, so we'll get x times the sine of 40 equals 12 times the sine of 80. And remember, we want to get x all by itself first, so dividing both sides by sine of 40, we get 12 times the sine of 80 over the sine of 40. Now that that puppy is all, x is all by itself, we can punch that in our calculator. And the real trick to it, regardless of what kind of calculator you have, is to punch this in first, right? So, and then hit equals. So we'll take 12 times the sine of 80, which was our entire numerator, and hit equals, and then divide that by the sine of 40, and we get our answer. Since it's a side length, we'll round to the nearest tenth, which is what the instructions say to do. So x was about 18.4. Now let's try number 2. It's the same setup. It's going to be the law of sines because they only give us one side length. So I need a side length, and I need the angle measure across from that. Well, they don't actually give it to me, but we can figure it out because we know two angles in this triangle. So if this is 52 and that's 91, you take 180 minus both of that stuff, and you get 37 degrees. So we'll say the sine of 37 over 20, right, that angle and the side across from each other, will equal, since x is across from the 52, we need to use the 52, the sine of 52 over x. And then we solve by cross multiplication. Equals 20 times the sine of 52, and then x equals 20 times the sine of 52 all over the sine of 37. And now that x is all by itself, we punch it in our calculator. 20 times the sine of 52 and hit equals. And then divide that by the sine of 20. We get, no, time out, what did I do wrong? Punched the wrong thing in, my bad. It is 20 times the sine of 52, which is that, divided by the sine of 37. My bad. I totally looked at the wrong thing. There we go. 26.2 is what we should have got. My bad. Sorry about that. So x was about 26.2. Let's try that puppy again, right? The big thing on this front side is how come I have to use the law of sines and not the law of cosines? One, it's not a right triangle, and two, you only have one side length, right? Sine, one side. So I need an angle measure and a side across from it. Don't really have that, so I got to figure it out for myself. 84, 34, 62 degrees. All three angles have to add up to be 180. So the sine of 62 over 16 will equal, I need x and the angle across from that puppy, the sine of 84 over x. Now we cross multiply. 16 times the sine of 84. So x equals 16 sines of 84, excuse me, over the sine of 62. And now I'll punch that in my calculator. 16 times the sine of 84, hit equals, divided by the sine of 62. And rounding to the nearest tenth, that's about 18.0, right? Don't discriminate against 0. It's a number just like everybody else. So 18.0, right? When they say round to the nearest tenth, that's how you do it, right? Don't say that's 18 because that's rounded to the nearest whole number. One more of these. Let's do number 4 right here. Get that puppy set up for me. Why don't you pause the video and see if you can set up your proportion without me. So you should have had the sine of 72 over 25 equals the sine of 17 over x, right? You need a side length and an angle across from it, and etc. So solve by cross multiplying. And then x equals 25 sines, if I could spell it right, sine of 17 over the sine of 72, and we punch that in. 25 sines of 17 equals, divided by the sine of 72 equals, boom, about 7.7. So let's go to the story problem here. It says 3 cities form the vertices of a triangle. The angles of the triangle are 40 degrees, 60 degrees, and 80 degrees. So we can grab our geometer and draw ourselves a triangle. We know we can eliminate some of the shapes on our geometer. We can definitely eliminate the right triangle. It's not a right triangle. It's not going to be an isosceles triangle, and it's not going to be an obtuse triangle or an equilateral triangle either. So probably shape 2 on your geometer would probably be the best triangle to draw here. This kind of looks like this. There's 3 cities involved. They don't tell us the name, so we'll just call them A, B, and C. And then I'm going to go by looks and just say, all right, angle C looks like it's the smallest, so I'm going to put 40 degrees in that one. And then angle A is the next smallest, so 60 degrees, and then 80 degrees. So just got my setup. Then there's more information coming here. It says the 2 most distant cities are 40 miles apart. Well, you know, out of between A and B, B and C, and A and C, which ones are the farthest apart, because they're across from the largest angle. 80 degrees is the largest angle, so 40 miles goes between those 2 cities. A and C are the farthest apart. How close are the 2 closest cities? Well, that would be from A to B, because that's the smallest angle, so they want that to be x. Since we only know one side length, we will use the law of sines that says the sine of 80 over 40 will be proportional to these 2 brothers, the sine of 40 over x. And x equals 40 sines of 40 over the sine of 80. And don't think that those reduce, like the sine of 40 or a sine of 80. No, that doesn't reduce that way. You can't do that, so we'll just punch it in. 40 sines of 40 equals, boom, divided by the sine of 80 equals about 26.1 miles. Bingo. That was the law of sines. Now to the backside, the law of cosines. They give you all three cases again. I think that that's kind of overkill. Let's write this. This is my little generic law of cosines because they're always asking you to find x. So let's say that little x squared will equal b squared plus c squared minus 2bc times the cosine of big X. This is the one I like to use each time. And you can see so far that this is not a right triangle. We don't have any information to say that it is a right triangle. And they give me more than one side length. More than one side length. So, when it comes to all these parts right here, x is obviously the side length you look for, little x, right? Big X is the angle across from little x, right? So these two kind of go together, right? One's the side length, one's the angle measure. B and C are the two sides that you were provided with. It doesn't matter which one's which. But when it comes to calculating this stuff, we just kind of got to be careful here. So let's just kind of set up. They want me to find this little x right here, so it will be little x squared will equal b squared, which is 14 squared, plus 12 squared. It doesn't matter what order those two things are in, minus 2 times b times c. 14 and 12 go in there, times the cosine of that angle measure, which says 62 degrees, I think. Yes, 62 degrees. So notice that's how we set it all up. X is the side length we're looking for, big X is the angle measure, and 14 and 12 are the B's and the C's, and it doesn't matter which one's which. They want us to get X all by itself. Well, it's almost all by itself already. It's being squared, right? So what we got to do is figure this out over here, but we're going to clean it up a little bit to make it easier to punch into our calculator. So here's what I'll have you do. I'll have you figure out what this is right here, 14 squared plus 12 squared. Just punch that in your calculator. What is 14 squared plus 12 squared? And you should get 340. Then minus, go ahead and punch in 2 times 14 times 12, and hopefully you get 336, and the cosine of 62 is still there. So all I did was clean that up just a little bit to make it easier to punch into my calculator. Now realize that we always have to follow the order of operations. Like for example, if I gave you something that looked like this, 5 minus 2 times 3, according to the order of operations, you always have to do multiplication before you do subtraction. Well, you see that there's some multiplication going on right here. You can't actually take 340 minus 336 and write this as 6 cosine of 62. It doesn't work that way because there is multiplication going on right here. So what we really want to do is just punch this in our calculator. Let's take 340 minus 336 cosines of 62. And we get this, 182 point blah, 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 blah. Well, let's go jot that down, because realize that's what x squared is. It's about 182.26 blah, 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 blah. I want you to put that dot, 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 because realize that that kind of tells me that you haven't rounded anything. You're just going to keep that exact in your calculator, and then you want to square root that. So you can, if you have a smart calculator, hit second, square root, and then you should have an ANS button somewhere down there near your equal sign. It might be a second function, but mine, I know it's really hard for you to read that, but it stands for your previous answer. Now, if you have one of them backwards calculators, all you have to do was have that punched in right there. You type in 340 minus 336, 62 cosine equals, and then hit your square root button, and it should get you to about 13.5. If you can't get it, just come on in and I'll show you how to punch that in your calculator, but at least you can watch this to see the setup, and all you're missing is the keystrokes of how to actually punch that in. So let's try this puppy again. Notice they give me more than one side. They give me all three sides here, so that's going to be a law cosine situation. Let's set it up to where it's little x squared. Remember, little x is the side across from the angle we're looking for. Well, in this case, this is the angle we're looking for. I need to use this side as my x, little x value. So 10 squared will equal 11 squared plus 12 squared minus 2 times 11 times 12 times the cosine of big X, right? We're looking for an angle measure, so that's why this is the variable, and the side across from that is the dude that goes all by itself. So we can do some cleaning up now. 100 will equal, go ahead and punch 11 squared plus 12 squared in your calculator. 11 squared plus 12 squared is 265, minus, take 2 times 11 times 12, and get 264 times the cosine of x. Now, remember, you can't take 265 minus 264 because of this multiplication going on here. It's the order of operations. We want to try to get cosine of x all by itself. For example, think of it as an easier situation here. Let's just use an eraser, Mr. P. If I told you that like 7 equals 5 minus 2x, what's the first move that you would do to solve for x? Well, you got to get this 2x by itself. Don't you subtract 5 from both sides? Well, that's what we want to do here. We want to subtract 265 from both sides because we have this being added or subtracted to the term with the x in it. So let's subtract 265 from both sides. And when you do that, you get this. Almost. Sorry, hit the wrong button there. And you get negative 165 over here, and all this stuff came down. Well, now to get cosine of x all by itself, we're going to divide by negative 264. There's a times 264 right there, so we're going to divide by negative 264. But we're not even going to worry about simplifying it, except for the fact that it's a negative divided by a negative. We'll have 165 over 264 as a fraction over here equals the cosine of x. So all we did here was divide both sides by negative 264 and cleaned up the negative over the negative, which made it turn into a positive. Now that we have the cosine of x all by itself, we can solve for the missing angle measure by doing the inverse cosine. So the cosine inverse of 165 over 264 will equal x, right? So that's that second cosine function, the cosine inverse of 165 divided by 264. And that gives you that, and they say round all the angle measures to the nearest degree, so that would be about 51 degrees. So x is about 51 degrees. Holy cow, that was a lot of stuff there. Let's give it another shot here. 1, 2, 3 sides given to us, more than one side, and it's not a right triangle, so we will set up our law of cosines, and this is the angle measure. We start with the side across from it. Other two dudes, we don't really care what they are. Times the cosine of big X, right? So miss an angle measure, etc. Let's do a little cleaning up. 16 squared is 256. And then 18 squared plus 24 squared, we can punch that into our calculator. And that is 900 minus 2 times 18 times 24, which is 864. And the cosine of x is still there. Now our next move is to subtract 900 from both sides. Right, we're trying to get this term all by itself, so subtract 900, and then finally we will divide both sides by negative 864, and we'll have a negative divided by a negative again, so that will turn out positive. So I'll have 644 over 864 equals the cosine of x. And then finally, that cosine of x is all by itself. We do the inverse cosine of 644 over 864. Yeah, can't write this morning. Equals x. Now we punch that in, and since it's an angle measure, we'll round to the nearest degree, and you should get about 42 degrees. So let's see if we can get the last one set up. Again, they're giving us more than one side, right? So it's the law of cosines. But we do know the angle measure. We're missing x, so that's one of these where it's x squared equals 25 squared plus 20 squared minus 2 times 25 times 20 times the cosine of 82. Notice that x is all by itself. X squared is all by itself. We want to clean this up just a little bit so it's easier to punch in our calculator. So just figure out what this is. And that's 1025 minus 2 times 25 times 20, which is 1,000. And then there's the cosine of 82. So we will punch all that in our calculator. We'll take 1,025 minus 1,000 cosines of 82 and get that. And then we'll jot that down. That's about 885.8. So that's x squared is about 885.8, blah, 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 meaning that you haven't rounded that yet. You've kept it in your calculator because you need to square root that now. So you can use your previous answer button and get about 29.8. Since it's a side length, they want us to round to the nearest tenth. So x is about 29.8. One more. Two cars start moving from the same location. So let's say this is where they start from, right here. They head straight but in different directions. So let's say that this is our first car going this way. First car. The angle between where they are heading is 43 degrees. So let's do a good enough sketch. We don't have to necessarily measure it, but you definitely don't want to do this because that's way too big. 43 degrees, about like meow. And the second car, that would be second car, and that's 43 degrees. It says the first car travels 20 miles, so 20 miles. And the second car traveled 37 miles, so I did do a good job with my picture. Maybe I'll erase a little bit of this, because just to make it look right, 20 miles, 37 miles. 37 is a lot further than 20. So how far apart are the two cars? They are asking us for this right here. How far apart the two cars are. So we'll call that x. And this is a law of cosines because I have more than one side. So I will set it up as x squared minus 2 times 37 times 20 cosines of 43. And then do a little cleanup. Punch in 37 squared plus 20 squared, and I get 1769. 2 times 37 times 20, 1480, and it was negative right there, times the cosine of 43. And then I'll punch that in, and that's what x squared is about. So I punched it in, and I got about 686.59, blah, 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 blah. And that needs to get square rooted, so I will second square root that answer and say x is about 26.2 miles. So homework is all from a packet. Let me know if you have any questions. Be careful, they mix up sines and law of sines and law of cosines, so figure out what you need. If they give you one side, it's law of sines. If they give you more than one side, it's law of cosines. So have a good one.